Hey there, my friends. Welcome back. Rob Franek, Editor-in-Chief here at the Princeton Review. And today, folks, we're sharing the top 8 AP statistics concepts to help you crush that exam come the springtime. But before we do, let's cover some of the exam details. Now, the AP statistics exam is a 3-hour test made up of 2 parts, a multiple choice section and a free response section. The multiple choice section consists of a whopping 40 questions, which you are given an hour and 30 minutes to complete. The second section consists of 6 free response questions where you'll be expected not only to perform the right computations, but also to communicate your reasoning and justify your answers clearly. Regarding calculators on the exam, the College Board, the creators of all things AP, absolutely expects you to bring a graphing calculator with statistical capabilities to the AP statistics exam. In fact, you will be at a disadvantage if you don't have one. A good graphing calculator will not only save you time and prevent you from making minor arithmetic mistakes, but it will also help you compute descriptive statistics such as standard deviation and correlation coefficient and regression analysis. And let's also remember that calculators are also capable of making graphs such as histograms and, of course, scatter plot graphs, which are incredibly useful on this AP statistics exam. That all said, please don't bring an unfamiliar calculator to the exam. Because, of course, folks, time is of the essence on test day, so become familiar with how to use your calculator and what its capabilities are well before exam day. Friends, those are the basics. So let us, without further ado, jump right in and take a look at the key concepts that you'll need again to master to ace this exam come the springtime. Concept number 1, exploring and interpreting data. Now, in total, you'll find 8 to 12 questions in the multiple choice section for this particular concept. Now, statistics is, of course, the science of data. But you, friends, are rarely given raw data. So you'll need to know how to properly interpret data that are summarized in, of course, charts or tables. And let's remember that variables are the building blocks of data, my friends. So you need to know the key data types, categorical or qualitative variables. Now, those are categories such as eye color and, of course, sex. Quantitative variables are numerical, such as height and weight. Data types themselves will dictate what types of analysis that you can perform. So, for instance, you can calculate an average height, but you can't calculate an average eye color. However, you can calculate a mode for eye color specifically. Now, for quantitative data, you'll also need to know if the variable is continuous, such as height, or discrete, such as the outcome of rolling dice. The easiest way to summarize data is through descriptive statistics. The simplest form of summarizing data is through tables. You all know this. The most common tabular representation is through frequency tables, which tell you how often something was observed. Now, frequency tables can also help you see data variation and clustering and, of course, central tendencies. Now, to efficiently convey complex information, a chart or a graph can be used, of course. So here you need to be familiar with pie charts and bar graphs and stem plots and dot plots. Normally, those are for smaller data sets. Larger data sets are typically represented through box plots as well as histograms. So let's remember that numerical methods are more commonly used because they are precise and they are used in a wide variety of ways for making statistical inferences. So these methods are applied in univariate data, meaning exploring one characteristic, and bivariate data, of course, exploring 2 characteristics. Now, there are level of course, interdependence between those 2 bivariates. Now, concepts that you need to be familiar with are measuring of central tendency. So as in, what is a typical data value? Now, these measures are, and you'll be familiar with all of them, mean, median, and of course the last one, mode. Each conveys a different piece of information, and its utility depends on the question that you're trying to answer. Now, data spread describes how far the data are from the center. These measures include range and standard deviation and quartiles and percentiles. Finally, friends, you'll need to be able to describe the distribution's shape. Specifically, is it skewed one way or the other? Is one tail longer or fatter than the other? Or is it a symmetrical distribution? Other terms that you'll need to know are outliers and clusters and gaps. That brings us on to concept number 2, which is all about methods of data collection. Now, you can expect 4 to 6 questions on the multiple choice section and 1 free response question in this category. Now, to draw valid conclusions from a study, you need appropriate methods for both collecting as well as analyzing data. Now, questions here relate to planning a study and spotting what could be wrong with a specific study or its analysis. You need to know the difference between a population, all members of a certain group, and a sample, a selection of members of a certain group. And you need to understand, when do you need to conduct a census, study of each member, or a sample, only a representative selection of a group, to make inferences about the population. Additionally, you'll need to know the difference between experiments where the experimenter changes variables, as in scientific experiment, and observational studies where the experimenter observes relationships among the variables, as in economic studies. That brings us on to concept number 3, which is focus on sampling methods themselves. Now, you can expect 3 to 5 questions on the multiple choice section. Determine, friends, how to draw valid population inferences from a sample data. Now, valid inferences hinge on choosing representative samples, so the discussion is primarily focused on invalid or bias samples. Now, bias can arise from self-selection. Only those with a favorable opinion are likely to fill out this particular survey, or convenience. Only those subjects that can be reached are surveyed, and judgmental selection, where respondents are selected solely on subjective criteria. Now, there are, of course, some ways to ensure random and hence representative samples through systematic sampling, stratified sampling, proportional sampling, and the last one, cluster sampling. So be sure to know the definitions and the differences among them, specifically those types of sampling modes. You'll also need to know the major sampling errors and their causes. Now, this will include response bias, usually when respondents inflate their responses; non-response bias, which when respondents that don't respond are statistically different than those that do; under coverage, when not enough respondents in a certain category are left out; and of course, wording effect bias itself. So be sure to review these concepts in detail in your prep book for this test. That leads me to concept number 4, which is focused on planning and conducting experiments themselves. Now, this will show up in at least 1 free response question. The most important objective here is to design an experiment or conduct a study so that the results adequately answer the study's question. Now, before conducting the study, you need to be familiar with variables. Independent variables are those that an experimenter controls and changes. Dependent variables are those that the experimenter varies. That said, while these are the main variable types, you also need to be aware of explanatory variables, which affect the dependent variables. A quick example just to highlight this point. A researcher is studying the degree of homesickness of college students based on how far college is from home. They may use midterms as an explanatory variable. Now, confounding variables are those that make it difficult to separate the effects of 2 or more variables. So, for example, most diabetics also have high blood pressure. A study evaluating the effects of high blood pressure on heart attack may not be able to separate diabetes from high blood pressure in the evaluation, as both variables occur simultaneously. Next, my friends, you need to understand the concept of an experimental unit, which is the smallest unit of the population used in the study. Experimental units can be divided into groups. A control group has not had treatment applied to it, while a placebo group is given a treatment which looks and feels like an experimental treatment, but it is expected to have no effect. Now, you are also expected to know which experimental designs need a control group or need a placebo group. So be sure to look these up well before test day. Finally, experimental studies can be single-blind and double-blind. And the difference between the two is that single-blind studies, the subject does not know if he or she is receiving the experimental treatment or a placebo. In a double-blind study, both the subject and the experimenter do not know if the subject is receiving the treatment or the placebo. So, of course, friends, be sure to review under what conditions which experimental design is appropriate. Concept number 5, folks, it's all about probability and anticipating patterns themselves. Now, this concept is likely to appear in 8 to 12 questions overall on the multiple choice section and up to 2 free response questions. So now this is a big concept. And while it may look and seem intimidating, the extra effort that you put in right now to understand this will pay off big dividends on test day and probably much beyond that into your future lives. Now, probability itself measures the likelihood of an event. It is usually expressed as a fraction or a decimal and is always between 0 and 1. Now, for the AP exam, you not only will need to know some probability formulas, but you'll also need to be able to visualize them in tree diagrams as well as Venn diagrams. First off, the variables that you need to know if random variables are discrete or continuous. If they are discrete, then you can find the probability of a certain value. If they're continuous, then you are looking for the probability of the variable occurring between 2 values. Concepts that you need to know are going to be probability distribution functions and, of course, cumulative density functions. Other concepts that you need to have up in your noggins are independence, expected value, and, of course, variance. Now, special distributions that are also covered include binomial and geometric distributions for discrete variables and normal distributions for continuous variables. That wraps up concept number 5. On to concept number 6, which is about the normal distribution. This is also known as the bell curve or the Gaussian distribution. It is the most widely used distribution as it closely approximates many different applications and processes. Some facts that you should have an instant recall in your noggins on test day about normal distribution are the following. It is continuous, symmetric around its mean, and bell-shaped. Now, the mean, the median, and the mode of a normal distribution are equal. The curve approaches but never crosses the horizontal axis. Near all data in the distribution, 99.73% lies within 3 standard deviations of the mean. The location of the distribution depends on the mean itself. The shape of the distribution depends on the standard deviation. Given these properties, the distribution can be normalized and a z-score can be used to convert between a normalized distribution and the experimentally determined one. You need to know how to use the z-score and how to combine various random variables with different means and different standard deviations. Now, lastly, you should review the central limit theorem, which states that regardless of the shape of the population distribution, as the size of a sample increases, the shape of the distribution becomes more symmetric and bell-shaped. more like the normal distribution. The center of the distribution of x remains at the mean, and the mean of the sample equates to the population mean, and the spread of the sample data decreases. That's concept number 6. Concept number 7, my friend, estimation and confidence intervals. Now, when experimenters are interested in exploring unknown information about a population of interest, they take samples from the population and use the information gathered to make estimations. Now, this procedure of guessing an unknown value, uses the observed values for samples. It is known as the estimation process. Now, there are 2 estimation methods that you should know come exam day: point estimation and interval estimation. Now, a point estimate is a single value estimate of an unknown parameter. It makes no allowance for the uncertainty of the value's accuracy, whereas an interval estimate gives you the range of values where the parameter is expected to lie to compensate for the uncertainty of the estimate's accuracy. While a point estimate provides some helpful information, experimenters also like to understand how good their estimation is. In statistics, the goodness of an estimate is evaluated using confidence intervals and confidence levels. Now, a confidence interval consists of 2 numbers between which we are reasonably certain our true parameter will fall based on the confidence level we've chosen, which is typically 95%. You will certainly see questions of confidence intervals on the exam, specifically on how to construct a confidence interval. You'll need, of course, to review the following 4 steps used to properly construct a confidence interval. Step number 1, identify the parameter of interest. So, for example, the population proportion, the population mean, the difference in population portions, or another parameter of interest. Step number 2, identify the appropriate type of confidence interval and check its requirement. In this step, you should give the correct name of the formula for the type of confidence interval that you've selected. And folks, we should mention that if you select a wrong type of confidence interval, the College Board will not give you credit for this part of the problem. Step number 3, provide the correct values obtained from either statistical tables or your calculator to compute the confidence interval correctly. Show you are putting the correct numbers into the formula you already gave in step number 2. After you've computed the correct confidence interval, be sure to state it as a lower limit and an upper limit. So, for example, P equals 0.62, 0.68. That leads us to step number 4, the final step. You should state the correct conclusion in the context of the problem using confidence intervals. So, for instance, if your 95% interval for P is indeed 0.62, 0.68, then write, we are 95% confident that the proportion of voters in Iowa in favor of the governor's position is between 0.62 and 0.68. Lastly, different samples will result, of course, in different estimates, and how close or how far an estimate can be from its true value is answered by studying the distribution of the estimates. You should review the 3 criteria used to evaluate the quality of a point estimator, which are, number 1, the center of the distribution of estimates as measured by the mean. Number 2, the spread of the distribution of estimates as measured by the standard deviation. Number 3, the shape of the distribution itself. Testing a hypothesis. A statistical hypothesis is a claim or a statement about a parameter value. Now, the process by which a hypothesis is verified through sample data collection is called hypothesis testing. You need to know of the null hypothesis a statement assumed to be true unless proven otherwise, and the alternative hypothesis, a statement that must be true of the null hypothesis, is false. To get full credit on hypothesis testing questions, you need to complete the following 4 steps. Steps number 1, state the null and the alternative hypothesis correctly and define any notation used if you switch the null and alternative hypotheses around. You will lose all credit for this step in the AP exam. Step number 2, identify the correct statistical test. This means giving the correct name of the test or providing a correct symbol or formula for the test statistic. This is crucial because if you use the wrong statistical test, you will not get credit for this part of the problem on the exam. Step number 3, my friends, you'll need to provide the correct mechanics to show the problem. This means doing the math and providing the correct numerical value of the test statistics. So be sure to show that you are putting the correct numbers into the formula that you gave in step number 2. Step number 4, state the correct conclusion in the context of the problem using the results of your statistical test. In other words, use the results from step 3 to arrive at the conclusion. You'll need, of course, to state clearly the link between the conclusion and the test result. When answering any estimation or inference problem, be sure to read the entire question carefully. Some problems may require you to use all 4 steps that we just discussed today. Others may require you to only use a few. So you should also review error types. Type 1 error is the possibility of rejecting the null hypothesis when it is actually true. Type 2 error is the possibility of failing to reject the null hypothesis when it is in reality false. Finally, you are required to know about a test's power. Now, good tests have high power, obviously. The power of a test increases when, number 1, the sample size itself increases. Number 2, when the test 1 error rate increases. Number 3, the effect size increases. Now, friends, we encourage you to review these concepts and the overall process of testing a hypothesis in detail in preparation for the exam. Friends, again, as always, we have covered a ton of information today, but it is nothing that you can't handle on this AP Statistics exam. Please do pick up a copy of our AP Statistics book for in-depth review, as well as 4 full-length practice tests. And of course, as always, if you enjoyed this video, please do give it a thumbs up and share your thoughts with us in the comments section. And of course, if you haven't already, subscribe to our channel at the Princeton Review for the latest updates on standardized tests and college admission and extracurricular activities and study tips and much more, my friends. Rob Franek signing off for today. Be well. See you here the next time. Take care.